Okay, let's talk about transformations as a whole. So we're going to kind of summarize most of this chapter in a graphic organizer here for you. So transformations, first of all, geometric figures change in shape, size, or position. And transformations can either be an isometry or not. So let's go with the isometries first. So transformations that are an isometry, the pre-image and the image are congruent. So examples of these would be, first of all, a translation. So that motion is a slide. The orientation, or the way you read the points, stays the same. You can have a reflection, which is basically a flip. The orientation will be opposite. So if you read the name clockwise for the pre-image, you'll read the name counterclockwise for the image. And then a rotation is a turn, and the orientation stays the same, meaning, again, the way you read the points, you'll still be reading clockwise or counterclockwise. If a figure is an isometry, it also will have symmetry. And basically, symmetry is an isometry that maps a figure onto itself. And you've probably talked about symmetry in previous math classes or in art class. So there's three types of symmetries. Some can have more than one. Some figures have more than one type of symmetry. Reflectional symmetry is if there is a line, usually called the line of reflection, that divides a figure into congruent halves. So we'd call that line of reflection. So think about making those paper hearts maybe in elementary school when you folded the paper in half first and only draw half of the heart. Then you got the whole thing, so that heart would have reflectional symmetry. Rotational symmetry is if you can turn a figure 180 degrees or less and map that figure onto itself. So again, rotational symmetry, you rotate 180 degrees or less, and you get that figure to map right onto itself again. So for example, this figure would have rotational symmetry because I could turn it 180 degrees, and it would still be a rectangle length along the horizontal, width on the vertical. And lastly, we have point symmetry. And this is basically a figure with 180 degree rotational symmetry. So if you turned it about a point, let's say if I put a push pin in the center and I rotate it, if I rotate 180, I get the same rectangle. So a figure with 180 degree rotational symmetry. So these are our isometries, and what happens with an isometry, you have symmetry. Now let's look at transformations that are not an isometry, and that would be a dilation. The doctor's office, eye doctor, they dilate your eyes. That means your pupils are enlarged or they shrink. So this is a size change. So it's not in isometry because the pre-image and image are not congruent. And with a dilation, sometimes we call this a stretch or a shrink. And you may hear this when you get into Algebra 2 with parabolas and graphs, stretching and shrinking. And then again, just to make sure you review, a pre-image is the original figure, and an image is the resulting figure after a transformation. So there you have a quick graphic organizer on transformation.